Hi students, in the previous chapter we learned what a resistance was and we learned about Ohm's law. In this chapter we are going to learn how the resistance of a conductor actually varies when you vary the length of a wire, the area of cross section of a wire and the material of a wire. So we are going to learn the different factors on which the resistance of a conductor depends. First of all, to understand the resistance of a conductor better, let us conduct a simple experiment. Here, this is the experiment that we will conduct to understand how the resistance of a wire depends on different factors. To conduct this experiment, we have taken a circuit that consists of an ammeter, a battery and a key. Here's the circuit. Now, we have four components in the circuit. We have a nichrome wire which has double the cross-sectional area of the initial nichrome wire. We have yet another nichrome wire, this one, which has double the length of the initial nichrome wire but the same cross-sectional area as the initial nichrome wire. And we have a copper wire with the same cross-sectional area and the same length as the initial nichrome wire. I know, so many components. What are we going to do? First of all, let us connect a simple nichrome wire in our circuit. When we do that, we note that the ammeter reading is 0.1 amperes. Understood? Here's the reading. Now, let us see how resistance offered by the nichrome wire varies with the length of the nichrome wire. If the resistance offered varies with the length of the nichrome wire, then the ammeter reading should change, isn't it? Because when resistance increases, current decreases, and when resistance decreases, current increases. So here, now let's replace this original nichrome wire with a nichrome wire which has a length 2L, that is a length twice that of the initial nichrome wire. When we do that, we see that the ammeter reading becomes half of the initial one. The ammeter reading becomes 0.05 amperes. That's half of 0.1 amperes. This tells us that when we double the length of the nichrome wire, the current decreases by half. Or we can say that the resistance becomes double when we double the length of the nichrome wire. Isn't it? After all, if the resistance becomes doubled, then the current will become half. Isn't it? Because I is V by R, or current is inversely proportional to the resistance. So this is an interesting observation here, that when we double the length of the wire, the current becomes half, or the resistance becomes double. Now let us conduct this other experiment in which we will put a nichrome wire with double the area of cross section in this circuit. Here, now we have put a nichrome wire here with double the area of cross section compared to the initial nichrome wire. What do we see? We see that the ammeter readings becomes 0.2 amperes. That's double the initial reading, isn't it? The initial reading when we attached only the single nichrome wire was 0.1 amperes. What this means is that the current gets doubled when the area of cross section of the nichrome wire is doubled. Or we can say that the resistance gets halved when the area of the cross section of the nichrome wire is doubled, isn't it? So current becomes double, resistance becomes half if the area is double, or resistance is inversely proportional to area of cross section. So this is another interesting fact we found out. Does resistance also depend on the material of the wire? We can replace the nichrome wire by a wire made of copper of the same thickness and the same area of cross section as the nichrome wire. When we do that, we see that the ammeter reading is 10 amperes. When we connected a nichrome wire of similar area of cross section and similar length, we got an ammeter reading of 0.1 amperes. But with a copper wire, we got a reading of 10 amperes. That's 100 times the initial reading. Definitely copper has some special property that allows more current to flow, isn't it? And that offers less resistance. Copper offers much less resistance compared to nichrome. So there you go. This experiment tells us the different quantities on which resistance of a wire depends. It depends on the area of cross section, on the length of the wire and the material of the wire, whether we are using copper or nichrome.